Okay, for number 23, we have a typical integration by parts problem. Say u equals e to the negative x, and my dv will be cosine of x dx. My v then turns out to be sine of x, and my du is negative e to the negative x dx. I now have uv, that's a positive, almost look kind of weird. So I have e to the negative x sine x minus the integral, but since I have a negative in there, it becomes positive of e to the negative x sine of x dx. As you can see here, I need to use integration by parts again, so I'll pick a new u. My du will be negative e to the negative x dx. My dv is what was left over, which is sine of x dx. And my v is negative cosine of x. This now becomes negative e to the negative x cosine x minus the integral of e to the negative x cosine x dx. Okay. As you can see here now, we're going to have um, the integral of e to the negative x cosine x dx is going to equal this whole thing, which will be e to the negative x sine x minus e to the negative x cosine x minus the integral of e to the negative x cosine x dx. It's one of those problems with the integration by parts where this integral actually repeats. So if we um, move it over to the left hand side, we can actually solve for the integral. So I'll try to do this quickly. Again, let me remind you that if you get stuck on anything, the upside is you can go back and pause or review or whatever. Okay, so now we have the integral of e to the negative x cosine x dx will equal 1/2 uh, this whole thing, e to the negative x sine x minus e to the negative x cosine x. Right there. Okay, now we've done the integrating. Now we have to just worry about the bounds. These bounds go from 0 to infinity. Or in other words, we're going to evaluate it from 0 to b and find the limit as b approaches infinity. I'll rewrite this a little bit nicer. So it looks like this. 1/2, since 1/2 is a constant, I can bring it out to the front. 1/2 the limit as b approaches infinity. And I'm going to rewrite this so it makes my job easier. Sine of b over e to the b minus cosine of b over e to the b. Notice this turns out to be my f of b minus my f of a, which is sine of 0 over e to the 0 minus cosine of 0 over e to the 0. As I evaluate this, let me evaluate my f of a first. Sine of 0 is 0, so that's 0, minus cosine of 0, which is 1, and e to the 0 is 1, so it's minus 1. As I do my limit, I have a sine of b over e to the b. Remember, the sine and cosine are limited. They're going to be any value between 1 and negative 1. And so this will turn out to be 0 because it's a small number divided by a really large number. 0 minus 0. My f of b minus f of a turns out to be 0 minus negative 1, or in other words 1, times that constant that we brought out in the beginning, times 1/2. So my answer is just 1/2. And there you go for problem number 23.